Okay, so here's our formula that you'll see, and this is sort of generic here. This is the force of friction equals some coefficient of friction, right? And this is how slippery an object is, right? So 0 would be very slippery, 1 would be very not slippery. Okay, so this coefficient is something between 0 and 1, and then R is how hard the surfaces are pressed together. That's that reaction force. Okay, and basically what this boils down to is if we've got a surface, right, like this, where the reaction force is essentially equal to mg, our force of friction almost always equals mu times m times g, okay, on a level surface. Now, the only time it would not equal this is if like somebody pressed down on this box with some force, and then of course it would be what mg plus whatever that force is how hard they're being held together, okay? So this is the basic idea of the force of friction. So this thing has to be given to you or you look it up. That's the mass of the object. That is the acceleration or the gravitational field strength, okay? This is going to be in newtons. This is in, it's a pure number, so it doesn't have units, right? And then of course this guy would be, the reaction force would be in newtons, okay? So let's just take a look at some of these coefficients of friction. This is the mu, right? Okay. Notice that they call this static. They're calling dynamic friction kinetic friction. I'm more used to kinetic friction, but dynamic also works. Notice that that things that are slippery have small coefficients, like Teflon on steel and air, right? Very slippery, right? Things that we would expect to be not very slippery, like rubber on dry concrete, have large coefficients. Okay, rubber on solid surfaces, well, if it sort of glues itself down, it could get coefficients bigger than 1, which is a little crazy, right? Notice that there's 2 columns, and that's because this is the friction needed to start something moving. This is the friction needed to keep it going, for dynamic, for it to slide, right? These things tend to be less. That is, if you push on some object, right? If you make a force versus time diagram here, right? You tend to push harder and harder and harder and harder, and suddenly it'll slide and the friction will drop down like that. That's very, very typical. Okay, so here I am increasing the force, and then when the object starts to slide, it slides more easily than it first starts. And that's because the surfaces actually kind of stick together a little bit, right? If you don't want to use a non-scientific term like stick, you can say they form weak molecular bonds, okay? These are approximate, so don't write these down like, oh, this is like the melting point of lead at 1 atmosphere or something like that. And then how are they related? We already talked about this, right? And I showed in class how this happens with the force probe. Okay, in the next video, we're going to get into the 2 types of friction a little bit.